Okay, good morning. So let us continue the lesson. I have asked some of the students from the other group B physically here. I don't know how much they will keep their promise, but after that we go to the other lesson. You can ask your questions about other courses if you want to know more from them. Okay. So let us continue the lesson to finalize everything actually today. So do you remember we talked about trigonometric equations? I told you that there are three types that you need to know. One type was sine. This we learned that last time. Sine of something is a number k, and k should be somewhere between -1 and 1. Do you remember what was the formula? Because you need to remember this. This is not included in the formula sheet. So what are the possibilities? What is inside the box? You should imagine several times the unit circle to remind yourself, and then you will be memorized. Yes?
The sine inverse.
Yes?
Of
Okay, so you really don't need your memory for that part, because that is just Math 1C lesson, yes? And then, what you need to add, do you remember the notion of rotating full circles, yes?
Yeah, n times
360. So you see, it's not hard to remember. But of course, you need to remember something else here, or, do you remember what was that or?
The 180.
Yes, because the other one is on the other side, yes, because I want to have the same. So it is 180 minus this number. But of course, again, you can go around. So this is why you add them. So it's not hard actually to remember that by just visualizing it. After a while, you will learn it. Okay, so the other one we learned is that sometimes this happens. So this is an or here, and it is very important. In the exam, you should be careful. So you need to emphasize what n is. N is an integer. Okay, and then we learned that what happens if I have sine of a box equals to sine of something else. What is the connection between these two? Of course, one possibility is that what is inside the box is exactly equal to what is inside the circle, but this is not the case always for some functions, including sine function. So we learned that what is inside the box is equal what is inside the circle, but of course, there is no guarantee that they have to be exactly equal. They might differ by an integer multiple of 360 degrees, because if this happens, they will end up at the same point on the unit circle, regardless of the values of these things. The signs are the same. Or you can just write the same story here. What is inside the box is equal to 180 minus what is inside the circle plus n times 360 degrees, yes? And again, I emphasize this. Now today, I want to answer this question for cosine, and a little bit technical one is for tangent, so we want to finalize this today. So what is my question now? If I want to write an analog of this, so it would be cosine of the box is equal to k. Again, I have the same restriction on k, because cosine is related to the x-coordinate, and x-coordinate cannot be less than -1, cannot be bigger than 1, because I am confined on the unit circle. So now we want to guess something here. Not guess, analyze that and write the formula here. And whenever you want to remember it, you need to visualize it, okay? So remember again your famous precise ruler and protractor. So you want to measure this angle, okay, physically. So what you do, you just draw a unit circle here. But my goal is to make cosine equals to k. And I know that cosine is the x-coordinate. So I will take my precise ruler, I don't know, I measure this distance. For example, assume that I measure this distance and it becomes exactly equal to k. And then what I have to do now? Yeah, I draw a vertical line. Yes, I draw a vertical line. So let me change the color. I draw a vertical line, then I will see that I have two I have two intersection points. Yes? And then if I connect this point to that point, this would be one of those angles that I am looking for. But of course, it is clear that the other angle is this one. Yes? This angle. So I will talk about this angle in two different ways. Okay, so let me just write one of them. Can you just write one of them here? So if someone tells me that cosine of the box, which I don't know, is equal to k, what can I conclude about the box? The box is equal to, of course, cosine inverse of k. Cosine inverse of k gives me this angle, the angle corresponding to this endpoint. But of course, this is again not the whole story, because I can go around the circle in any number of times that I like to. I will end up with the same point. And when I end up with the same point, it means that my x-coordinate is the same. So I hope that you agree with me. Again, I have to add this at the end. Is that understandable? But what is the other angle? So there's another scenario going on. Or, okay, can you tell me what should I write? What should I write? Yes? You want to say something? Just say it. It might be wrong. Yes.
It is wrong.
Come on. What is the other angle? Yes?
Is it negative cosine inverse of k plus n?
Yeah, that's one possibility, which is written in the books mostly like that. But might be you think, because I told you that you always have to measure the angle from this line, so you might say this is the other angle, which is correct. That's the other angle. So if you write, what is the other angle, by the way? It is 360 degrees, yes? 360 degrees minus this cosine inverse. Because cosine inverse is this angle. This is one possibility. There is another possibility, which is this angle. Do you agree? Because of symmetry, if I ask you what is the size of this angle, exactly this is equal to this one. And this is cosine inverse. So if I want to find this bigger angle, I need to subtract that angle from 360 degrees. This is, of course, completely true. So in the sine case, the second option was 180 minus that, because the other one would be on this side. But in cosine, the other one is in this side. So it would be 360 minus cosine inverse. This is one way to do that, but there is a better way to do that, because, do you know, in trigonometry, we also consider negative angles. Yes? This is positive. So if I ask you if I draw this picture for you, if I ask you if this is theta, and then what is another name for this angle, you can say it's minus theta, because it is going with the same magnitude in the wrong direction. Yes? So usually you don't see this written in books. They just write minus cosine inverse of k. And that's understandable, yes? Because this has two names. Of course, infinitely many names, but two of them are famous. One of them is 360 minus this one. One of them is minus cosine inverse. Is that understandable? So this is why people write it in this way. And the reason that they write it in this way is understandable, because you don't need to write two times, you know. Of course, this also clear, because I can go around. So this is why you can write it in compact form. This is the only reason that people drop this. They can write it in compact form, plus or minus cosine inverse of k plus n times 360 degrees. Yes, so that's a more compact way of writing both formulas. This is not one formula, of course. This is two formulas written more compactly using this symbol plus or minus. Yes? So this is why it's better to choose this name instead of that name. If I choose that name, that's completely correct. You can choose that name, but you need to write two separate formulas. Yes? Is that understandable? Okay, so now can you cook up this story for that? If I have two cosines equal together, then what can I conclude? Okay, this should be easy now. So one possibility is, of course, that this is equal to that. Yes. But plus what? Any multiple of 360 degrees. Another possibility is that you have negative of that, so it becomes plus and minus. Yes, as simple as that. N belongs to C. So that these are extremely important to understand and visualize every time, so that you can be quick in visualizing them. So this is the situation for cosine. If cosine is equal to a number, then of course this is the formula. If the two cosines are equal together, you can also conclude that. Yeah, understandable? So let me give you some examples before going to the next part. So I would say solve the following equation. So just let me write solve. So number one, assume that we have this 2, for example, cosine of 5x is equal to square root of 3. We want to find, when I say solve, it means that find all possible values for x, so that when you replace x with those values, the left-hand side becomes equal to the right-hand side. It doesn't mean just give me one answer, even though even math 4 students just put it in the calculator and calculate cosine inverse and they are done. But you need to know that when we say solve, it means that find all possible values, not in right angle triangle, in the general context of trigonometry. Okay, so what is the first step? If you want to solve an equation, you need to reduce it into one of these essential forms. Yes? So this is not exactly this one, it is not exactly that one, but it can be reduced to one of these forms, yes, by dividing both sides by 2, yes. So the first step to solve this, I divide both sides by 2, so this becomes 5x is equal to square root of 3 over 2. Is this number acceptable for cosine? Yes, because this number is smaller than 1 and greater than minus 1, so it is acceptable. Otherwise, you just immediately say that there is no solutions. And that is also solving equation. Solving equation means that find all possible solutions. So you would say that there is nothing possible here. Okay, but then what should I use? I use this version. The box is this one here. This is my unknown box. But I know what to do. The box 5x is equal to plus or minus, I'm using this lower version, cosine inverse of a square root of 3 over 2, and then plus n times 360 degrees. And of course, I emphasize that n belongs to z. Okay, but then this is a famous angle. I have it in my memory. If this is a famous angle, you have it. You can use the table, your calculator. But if this is not a famous angle, either I ask you to keep it exact. If I ask you to keep it exact, you just leave it like this. But if I ask you to calculate up to some decimal point, you put this in your calculator and choose the right number of decimal points, yes? So here, I have it in my memory, this is a famous angle. So do you remember, or something like that? Which angle? The cosine of that angle is the square root of 3 over 2. No, it is 30. 60 is for sine, yes? So this is a 30 degrees, yes? So it becomes 5x is equal to plus or minus 30 plus n times 360 degrees. And it's very important to put the symbol for degrees. Okay, I divide by 5 because I am not looking for 5x, I am looking for x at the end. So if I divide by 5, it becomes plus or minus just 6 degrees. Plus or minus plus n times this one divided by 5, which is
85.
what?
85?
No, 72. Yes? It's very close. Yes. Yes.
Ja, det är fint.
Yes. You're still reacting today.
Yeah.
It's Korean. Okay, so x is plus or minus 6 degrees plus n times 72 degrees. Yes? Oops, I have to put this degree. It's important. Okay, let us again, I want to make sure that you understand what you have achieved, yes? So what is the meaning of this? For example, can you give me a solution for this? You would say, yes, I will, for example, choose n equal to 0 because n is an integer. If I choose n equal to 0, I get two angles, 6 degrees and minus 6 degrees. If someone asks you, can you give me another name for minus 6 degrees? Because people might hesitate to write negative angles. But if you insist, you don't need to insist. If you insist to make it right positively, so what is another name for minus 6 degrees?
354.
Yes, 354, yes. So you can say that one of them is 6 degrees, the other one is 354. But of course, how many answers you got? Can you answer this question? Infinitely many. One, actually two, for each choice of n. If I put n equals to 1, then what happens? It becomes 72 plus 6, which is 78, one of them. But 72 minus 6, 66 is another one. So for each choice of n, you have an acceptable answer for that. So you got infinitely many solutions. Yes? Okay, so let me give you another example. Okay, let me just give you this example, and then we can move on to tangent, which is a little bit more technical. Okay, so here, number 2, let me write this, for example. Cosine 3x is equal to cosine of 5x. So we want to find x. So then it is clear that this is in the standard form like this. So the first one plays the role of the box here, yes? And this one plays the role of the circle. So what should I do? I can write 3x. There are two possibilities. 3x, what is inside the box, is equal to plus or minus 5x plus n times 360 degrees. But now you see this is not that useful, because even though we wrote it in a compact form, but from now on we have to separate it into two steps, because it depends. If it is positive, when I move it to the left, it becomes negative. When it is negative, when I move it to the right, to the left, it becomes positive. And I have to do that because I am looking for x. Yes? So this means that I have two scenarios. Number one, I consider 3x equals to 5x plus n times 360 degrees. And then I move this to the left. So it becomes minus 2x, because 3x minus 5x is equal to n times 360 degrees. And then I divide by minus 2, x becomes negative n times 180 degrees. Yes? But let me tell you something. If you remember the first session, I talked about this. You might solve this one, and when you check the faucet, you see that there is a positive sign there. Okay, so definitely, if the solution is this, and you check the faucet, you will find this in the faucet. Do you think that now you have made a mistake by a negative sign or not? Yes?
Both work.
Both work, actually. Yes, this is important to understand. So if you got this answer, but when you go to the faucet, that answer is written, it doesn't mean that you have made a mistake, because your answer is also correct. Why? Because the only problem, how you need to look at this, you need to look at the formula that you have got. If the formula generates the same angles, that is equivalent to your formula, yes? So here, why this formula generates the same angles? It's clear, yes? Here, when I put n equal to 0, I get 0. When I put 0, I get 0. That's okay. But here, when I put 1, I get 180. Here, when I put 1, I get minus 180. But minus 180 is also generated from here, but for choosing n equal to minus 1. So if you want to understand these two formulas are equivalent, you can just draw a unit circle for yourself and try to see where these angles are, and where is the end points of these angles. Where are they? So this is a multiple of 180. This sign just tells you which direction you go. So for example, you are standing here. If I put 0, you get 0. If I put 1, I get minus 180. So I have to move from this direction and I get here. If I put 2, it becomes minus 360 degrees. So I move here and go back to the same point. And if you put negative numbers, you go to in this direction. So this formula only generates 2 endpoints, yes? And this formula also generates these 2 endpoints, but the direction of movement is different. So this formula and that formula is completely equivalent, but which one do you prefer? Of course we prefer that one because we don't have extra minus sign. So yeah, that's on. I want you to understand that, but you can just leave it like that. So number 2, there is another scenario. I have to keep this minus sign. So it is minus 5x plus n times 360 degrees. I move this to the left, it becomes 8x equals to n times 360 degrees, and then I divide by 8. Divided by 8. So let us simplify by 4. Yes, this becomes 90 divided by the 2, and it's 45 actually. Is that right? Yeah, so it is 45 by the way. So it's n times 45 degrees. So another scenario is that you have this. So if you really want to combine all of them, that's also good to understand. So the first formula generates these 2 endpoints. Yes. And this formula, let us check where are the endpoints corresponding to this. If I put 0, I will get the same endpoint. If I put 1, I get 45 degrees, somewhere here. If I put 2, I get 90 degrees, it is here. If I put 3, 135, it is here. And then you see that every time I have to add 45. You see, I just want to ask you something, it's very important. This one, and then this one, and then this one, and then this one, and then that. Yes? So if you solve this problem and you go to the faucet, you will not see this one at all, you just see this one. And the reason is clear, yes? So don't think that you are making a mistake, because this formula on its own also generates those angles. Do you understand what I mean? So this formula generates 2 points, but this formula, when I wanted to check that, it starts again from this point, and of course it also covers some extra points, but it also covers these 2 points. So you don't need to emphasize by 2 formulas, yes? So if I ask you to solve this equation, you just write this. But I want you to understand why we can do that. Yes, is that understandable? So let me just repeat, this is important. This formula generates these 2 points only. Yes, but this formula not only generates these 2 points, but also generates some extra points, yes? But anyway, this formula covers these 2. So we don't need to repeat it, yes? So this formula is the best way of writing the solution of this one. Of course, if you write both of them, it is not wrong, but you are overemphasizing on something which is not necessary, and I told you there is a very important principle in mathematics is to be lazy. So don't write this which is not necessary, yes? You need to learn, do not write with something which is not necessary because I want you to emphasize, unless you want to teach something, and this is why I'm always emphasizing many things, yes? And most of the time you don't care, yes? You care when it comes in the exam. Okay, so is that understandable now? Okay, so that's very important to understand that these differences, you might solve the problem completely right, but when you go and check your faucet, it might be you get a different answer in the faucet. If your understanding is deeper, you should be able to convince yourself, if you have done everything right, that the formula that you get is equivalent to the formula which is written in the faucet. Okay, but let us leave this session to tangent. Okay, let us talk about the tangent. Tangent, momentarily, this protractor and ruler doesn't help that much. So yes, because we do not, why do you think that ruler and protractor, the way that we did it for sine and cosine is not that useful for tangent? Think a little bit about that. So my goal is to ask you this question. And this k doesn't have any bounds, yes? It can can be any number from minus infinity to positive infinity. Yes?
You can't measure it on the unit circle.
Yes, that because we have two axes, yes. One of them is the x-axis, which is related to cosine, and one of them is the y-axis, which is related to sine. If you remember, how did we define tangent? Do you remember? We said that the y-coordinate is sine, the x-coordinate is cosine, and then what is tangent? Yes?
They're divided by each other. I don't know which one.
Y over x.
Y over X.
Y over x is defined to be the tangent. Okay. But let us try to solve. Let me make it a little bit simpler. Instead of the box, let me just put x. X is your unknown, and instead of k, let us just write k. Okay. So what you do in Math 1C, you learned one of the answers. One of the answers is definitely this one, but this is not the whole story here at this level because we are supposed to find all of them. Yes. So for example, what you do. This is your unit circle. This I want you to understand something. So you, for example, you have your calculator, you calculate this angle and you see it, and then you, for example, use your protractor to measure it. So this is your angle tangent inverse of minus k. Okay, so immediately you can get infinitely more answers. This is trivial. What are the other infinitely many answers? Because if I stop here, I don't know. There is, by the way, let me write this alpha and beta, okay? Assume that the coordinates of this are alpha and beta, okay? So if I ask you, yes, so can you tell me other angles whose tangent is the same value? K. Yeah, that's clear, yes, because it doesn't matter. If this angle has the coordinates alpha and beta, if I go one full round in this direction, or one full round, or any multiple of full rounds in any direction, I will end up the same point. So it means that the tangent will remain the same. Why? Because both x and y coordinates remain the same. And tangent means dividing y coordinate by the x coordinate. So it is clear that the tangent will remain the same even though the angle is different. So one possibility is as before. I add that. But this is not that easy to, it is easy, not hard, but it is not that trivial as before. Is there any other point on the unit circle whose tangent is exactly that number? Yes, Ruben?
180 degrees, like that.
Yes?
Because you divide them and then they're minus.
Exactly,
both are minus.
exactly. So this is important. So if I ask you, if the coordinates of this point is alpha and beta, can you tell me what are the coordinates of the point exactly opposite to it? It's minus alpha and minus beta. Both of them are different from these. But the point is that when I'm talking about tangent, I have to divide y coordinate by the x coordinate. When I divide that, these minus signs are gone. So minus beta divided by minus alpha is exactly equal to beta over alpha. Yes, because these minus signs are cancelled. And if this happens, it means that not only this angle is acceptable for me, this angle is also acceptable for me. And as you said, this is just 180 degrees plus the angle that I got before. Yes? But again, the same story. So let me just make it short. So if I give you tangent of x equals to k, then there are two possibilities. Either x is tangent inverse of k plus n times 360 degrees, or x is equal, do you remember for sine it was 180 minus, but for tangent it becomes 180 plus tangent inverse of k plus n times 360 degrees, yes? This is also possible, it doesn't matter. If this point is here, don't worry, the other point would be here. But that's also possible. So what we got is completely correct, but the point is that you will not find this in the books. You can combine these two formulas into one single formula. This is why it's completely correct, 100% correct if you write it in that way. But you don't see this in your book, you see another version in your book. you see only one formula in the book. So they have combined these two formulas using these kinds of ideas into one single formula. Can you see that yourself? And how can I combine these two formulas into one single formula?
N times 190.
Yes, n times 180. So here, when I write n times 360, when I start here, I go immediately back to the same point. But there is another point in the way that I need to consider that. If I go 180 instead of 360, I will also catch up this point. And then again 180, I will catch up this point. Yes? So my point is to consider all angles corresponding to these 2 points. I can do it in 2 different ways, but I can do it just by doing it in one way. So if you combine these two, the answer would be tangent inverse of k plus n times 180 instead of, so this is combined into one single formula. Is that understandable? So this is the end of this story actually. So here, let me write it for you. And there is a crucial difference. Later we will talk in Math 4. 180 is the period of tangent. 360 is the period of sine and cosine functions. So we will talk about these things later. So that 180 and 360 are important to know later. Okay? But here at this moment, I want you to, actually you were able to discover it yourself. So you see it's not hard. But I would believe that after discovering it, because you need to send it to your memory, because most of the time later, this is just one part of one problem, you know. If you want to find everything from scratch again, it is possible because you just did it right now. You can do it probably in the future. But it's a problem, it's a compound problem. You need to solve everything from scratch. That would be impossible. Okay, so let me write it here for you. So if I have tangent of box equals to k, there is no limitation for tangent in this case. So then this becomes the box is equal tangent. So that is also important to remember. It is not 360, it is 180. Yes? And then n belongs to z. Okay, can you write the other version as well? So tangent of the box is equal to tangent of the circle. Sorry, yes. What can I write here? There's only one formula that I can write here. The box is equal to the circle. This is only one possibility, but there are infinitely many more possibilities. And that is this case. So this is exactly, I don't know why, we have to repeat everything more or less in Math 4. So I want you to learn that, and then in Math 4, of course, you will be a little bit more comfortable if you know already these things. But this is exactly the same thing. It's not, we cannot make it more advanced, but we can give you harder questions to solve. Okay? This is a simple task. So let me give you an example using these formulas, for example. How can we solve this problem? Yeah, let me make it simple. So tangent of x plus 35 degrees is equal to, let me put a 2 here. Let me put a square root of 3 here and 3 here. So for example, we want to solve this trigonometric equation. Equation means that I am looking for all possible x values so that when I replace x with those, the left hand side becomes exactly equal to the right hand side. And now, of course, you understand that it's not hard. You need to change the form of this so that you can get this standard form. Yes? And this is easy. You just divide by square root of 3. Okay, so if I divide, it becomes x plus 35 degrees. So what would be on the right hand side? This is important. I really want you to know these algebra things very easily. So can you just write something simpler here? Yes?
You multiply by square root of 3.
Yes, but what would be the answer?
Square root of 3 divided by 3.
No. Just the square root of 3, yes? Because 3, you can do it in a different way, you know? The square, this 3 is this one. Do you agree? So one of them is gone, so this is left. Of course, what you said is also working. But so what you said that I write it here, I multiply it by this and then divide it by this. 3 times square root of 3, this becomes square root of 9, which is 3, and then this one and that one is gone, you get square root of 3. So of course it's easy, but you can just visualize it in this very simple way in that way. So you see, if I divide 3 by square root of 3, the answer would be square root of 3. Anyway, yes, understandable? Okay, so let me clean this. But now, this is also, let me use this version. So this is playing the role of the box now. So the box, which is x plus 35 degrees, is equal to the tangent inverse of square root of 3 plus n times, be careful, not 360 degrees. If you write 360 degrees, it is not wrong, but it is not complete because you are not considering all the points. You are considering one part of the points, yes? So be careful, you have to write this. And then this is a famous angle, I have it in my memory, it is 60 degrees. Okay, and then what you need to do, you want to find x, so you don't need to divide, you just move 35 to the left. It becomes negative 35, positive 60, is positive 25. So the answer would be x is equal to positive 25 degrees plus n times 180 degrees. Yes? Understandable. Okay. Because you are supposed to be here until the next hour, we don't know what to do, let us solve problems, yes? So this is end of the lesson for this, but let me just solve you a little bit harder problems, okay? I don't want to solve it, I want to give it and I want to wait for you, okay? So what do you think, how can I solve this problem? So for example, I say 2 sine squared x. And by the way, you know that this symbol means what? Sine squared x means sine x squared. Yes, you will, most of the books, they follow this convention for writing the second power. Or the third power, it doesn't matter, sine k, x means sine x to power k. Okay, so this is the symbol that I am using. And then let me see what I'm supposed to do. Might be it's better to write it. So I need to write something that you can solve it. So yeah, let me make 2 and then let me make sine x and let me put it equal to 0. Okay, so I paused the video. I want to wait for you a little bit so that how you can solve this problem. So you see, this problem is not a standard problem. It is a different story, yes? Because the standard formulas are either sine equals to a number, cosine equals to a number, or tangent equals to a number. But this is not exactly one of those cases. So you need to use every knowledge that you have so far, including these things that you learned about trigonometric equations, combine them and be able to solve this problem. Of course, I'm exaggerating too much, it's not that hard, but I just want to see that what is the strategy. So let me just pause the video. Now you are, yes, now you can start. Okay, so let us see how Ruben is going to solve the problem for us.
Ooh, that handwriting.
Yes? Okay, just wait. Yes, that's completely true. But how did you come with this idea? Can you just say something?
I factorized this.
Yes.
Factorized
So
sine
you see, it might be, so if you understand, this sine x is now playing the role of your variable, which is x. So I'm sure that, if I can borrow that, if I give you this equation to solve, most of you realize how to solve. You factor x out. So you need to broaden your perspective. That's the same story, but it becomes a little bit more complicated, of course, because you know more, you know more things. Yes?
And then I move this, I divide by sine of x.
No, don't divide. Okay? The division is correct. Because when you, what is the problem with division right now? Because you can only divide if you are certain that that thing that you are dividing is not 0. Yes, but we don't know that yet because we don't know. Might be we are so unlucky that sine x is 0. So you need to use zero product rule. So remember this right now. Whenever you want to divide, you attempt to divide something, it's not working if that's a variable. Instead of dividing, you would say either this one is 0 or that one is 0. That's the 0 product. So just write it down. So you write sine x is equal to 0 or just write or 2 sine x minus 1 is equal to 0. So then you have 2 problems to solve, not one problem, yes? So if you don't mind, we can give them numbers and just write number 1, number 2. Okay? Now, forget about the main problem was hard. Now, assume that I have given you 2 simple questions, but in one question. Yes? One simple question is this, another simple question is this. Instead of one problem, you have 2 problems. But you just write number 1 here. Okay, and then start solving. Forget about number 2. Try to solve number 1. What is your suggestion to solve number 1?
Well, I kind of forgot the formula with the...
No, you come here. Let us generate the formula again here. Just come here. Sine x is equal to k. So just visualize a little bit. Everyone can help. So there are 2 formulas, yes? Can you visualize it in your head? One of them is what? In Math 1C. If I give you this in Math 1C, what is immediately in your brain?
This is k.
X is not k, no. X is?
Sin minus k.
Sin minus 1k, yes? But it is not enough here in this level because you can go full rounds plus n times 360 degrees. Yes, this is one scenario. Can you remember it immediately in your head?
Yeah, 180 minus.
Yes, exactly. So x is equal to 180 minus that one. Okay, so this is the way that you need to do in exam. If you have forgotten, you generate it and just put it in front of you, go back again. So you don't think that's a very hard thing to do. Okay, now go back here. Now your formulas are in front of your eyes. And if you need a number that you have forgotten, I can tell it to you. So x is equal to what? Zero, yes. Just continue. N times 360 degrees. Don't be in a hurry. Just do it step by step. Now, I would expect you should be able to immediately find it yourself by visualizing the unit circle. If not, I will give the answer to you. But can you just visualize the unit circle right now in your head? You need an angle whose sine is equal to 0. Sine is the y coordinate, so you want to make the y coordinate 0. Do you remember what angle is that?
0.
0. So it's hard now. So sine inverse of 0 is 0. That's end of the story. It is n times 360 degrees. Just write it equal to. You can write above that. It is 0. Yes. It is 0. Yes, and then it is this one. And I think it's better to put in a box. Make my life easier when I want to correct your papers. So, yes. So, write it in a box now. X is equal to this, and you need to emphasize. Someone might ask you what this n is. Don't think that because you know what n is, the person who is reading knows what n is. Yes, you need to write n belongs to this. Yes, that is completely true. That's very, very nice. Now, there is another scenario. You see, you have written it on the right-hand side yourself. You see, you generated the formula. Use the formula again to solve that. Yes, or yes?
So,
You need, yes, okay, but you already know what is that number? You have already put the curly bracket on top of that. What is that number?
yeah, that's 0.
That is 0, but now I have 180 minus 0. So it is 180, yes?
Yeah.
So just write it down. Okay. Put it in a box. Thank you. Okay, just one thing to mention. Here, when you have written this is good, here it is wrong. I would write arrow, yes? But then let me put the arrow here again. And then put x inside, yes? Okay, this is the true solution for this, but if you keep it in this way, that is okay. But always think, can you, if possible, sometimes it is not, most of the time it is not possible, but sometimes it is possible to combine formulas into simpler formulas. If you don't do that, you will not lose anything, unless I emphasize do this for getting the points, yes? But can you just do it yourself, or someone other? If you cannot do it himself, I will ask you. So you just draw a circle, draw a unit circle, and try to locate some of the points generated by this, some of the points generated by that.
So this would be just this point, the first one.
Yes, exactly.
And then this would be, yeah, this point and this point.
And this point and that point. So do you think that we need the second one?
Yeah, the second one, but not the first one.
Not the first one. Yes? Do you agree? Is that right? So you can just say, you can see that this is not necessary to write this one, because this is just giving you this. This on its own gives you both here and there, so it is enough.
Yeah.
So you can just say that safely, I can drop that one. But again, can you write this formula simpler? Yes? N times 180 is simpler than this version, because, so you see, now tell me, thank you very much. So here, you would say that all of them can be combined into 180 times n. Because your goal is to, you don't need to, wait, Ruben, you're supposed to solve this one as well. Okay, so here, x is 180 times n, because this, do you agree, this will generate both of them. Now, so you learned a lot, by the way. So you see, it was not hard. You didn't remember the formula, you visualized, generated the formula, put it in front of you. Instead of formula sheet, you have it in, you're generating the formula sheet yourself. And then you successfully imagine this one, and you were able to give this number to me. And you also able to conclude that this one is the only one needed. But if you just go a little bit more advanced, you realize this is enough. And of course, everyone agrees that writing just one single formula instead of these two formulas is much better. So this is a very nice way of solving this problem. I don't know, is there anyone wants to come here and continue the second one? Otherwise, Ruben himself continues. Come on, Kevin, why not? Jonathan, do you want to come? Yes, come on, thank you very much. To be brave, so much brave. Yes. Watch this one. Yes, I think, yes, we can only keep this. So we want to erase that, yes? But remember this one for me, so just write it above here. X is equal to 180, or n times 180, it doesn't matter. Okay, so this, and now you can erase everything except number 2 here. Yeah, because we want to solve, yeah, okay. I think if you clean this, this is enough.
Okay.
Yeah. And now we go to number 2. So this problem is not finished yet because it consists of 2 parts, yes? One part was that, the other one is this one. Okay, so now let us see how you solve the problem.
Oh, you mean this one?
Yes.
Oh, I thought, okay. Yeah.
No, that is harder, but let us start solving here, this one.
So 2 sine x minus 1 is equal to 0. So then sine x is equal to 1 over 2.
2, yes.
Just move that and divide by 2.
Yes.
And then we use the formula right there.
Yes.
And we get x is equal to sine inverse of 1 over 2 plus n times 360.
60, yes.
And we also get x is equal to 180 minus 1 over 2 plus n times 360 degrees.
Yes, and please put degrees on 180 as well.
Yes.
Okay, now I don't know if you remember, otherwise I can help you. Because it is not demanded from you to remember these numbers. Either you can use your calculator or you can refer to the table.
Yes, it's 180, right? Or what am I
No.
saying? It's 60, right?
No, 60 is for cosine, this is 30.
This is 30, okay.
Sine inverse of 1/2, if you check the table, you see it is 30 degrees. Yes, just put them there.
Okay, so then we get x is equal to 30 degrees plus n times 360 degrees.
Put them in a box, so that is one possibility.
And we get x is equal to...
You can do it in your head, yes?
Yes, 150 degrees plus n times 360.
Degrees, yes. Okay, so these are the solutions, yes? And I don't think I think you can convince yourself there is no overlap between these angles, and those angles. Yes, if you want to visualize that, these angles are these 2 points. So for example, if you want to visualize, how do you visualize this?
A little less than halfway. So
Yeah, it is
there,
30 degrees.
And,
No, not that one. Be careful, no. It's 150. For
yeah.
sine, it is exactly the mirror image. Not there, yes? So do you remember, for sine, one point is here, the other point is the mirror image. It's 150 now. So this end, we are making bold. This one. Okay. So you see, I have 4 points. This is capable of generating 2 of them, but this is capable of generating only this one. This is capable of generating this one. And you see that I cannot simplify it more than that. I cannot drop any one of them, yes? Because I need 4 points. Yes, this generates 2 of them, this generates 1 of them, this generates the other one. So this is the solution. So if you want to write it as a square, so what you need to write at the end, which is very helpful for the teacher who's correcting, so this becomes this, or x is equal to 30 plus n times 360 degrees, or x is equal to 150 plus n times 360 degrees. And of course, n belongs to z. So this is your answer. This is what you are supposed to generate. Yes? Thank you very much. Okay, by the way, are you willing? I want to publish it on YouTube. No problems?
Sure.
Yeah, okay. So anyone else? Now let us solve this harder problem. Yes? And so, if you need more time, I can pause the video now. Yes, do you want to think about it? Yes, let us see what happens. Then I will ask you to come back again if no one is volunteer. Okay, now you can start.
Okay, so first I want to make an auxiliary variable.
Yes, yes.
So I change...
A little bit louder, please.
So I change cosine of x to be y.
Yes.
And then we have 4y squared minus 8y plus 3 is equal to 0. And then we use ABC formula. And
Can you write a little bit bigger?
Should I erase and write bigger?
Yes, yes. And please do it stepwise completely. Don't do something in your head.
Okay.
You want to explain to someone who doesn't know actually.
Okay.
Plus 3.
Plus 3 is equal to 8y.
So usually when I write this, I say that, do you understand? Yes,
you
something
understand?
like, yeah, please, yes.
Okay. Does everyone understand how we go from this to this?
Yes.
Okay, good. And then we move 8y to the left hand
Yes.
side.
Yes.
And we get y squared minus 8y plus 3 is equal to 0. And then we use the ABC formula. And we get...
If you have forgotten the ABC formula, I will write it down there. Yes.
Yes, so the ABC formula is negative b plus or minus the square root of b squared minus 4ac AC over 2A, in which A is the 1 to the second power, B is the 1 to the first power, and C is the 1 to, well, with
Constant.
no powers.
Constant.
The constant, yes. So then we have negative this, which is negative 8, plus and minus the square root of this term squared, negative 8 to the power of 2, minus 4 times the first term, 4 times 4 times the third term, times 3, divided by 2 times the first term, 2 times 4. Okay, and then we get 8 plus or minus, this is
No, you can do this in your head.
Okay.
Yes, it is 64 minus how much? 48 is 16.
16, square root of 16 divided by 8, which gives us 3 over 2 and 1 over 2. And since cosine of a number can only be equal to between 0 and 1, this one gets crossed out because it's too big. So then we have this answer left, and we know that this is equal to y, not cosine or not x.
Yeah, yes.
So then we write cosine of x is equal to not y, we can just write 1 over 2.
Yes.
1 over 2, and then we take x is equal to plus or minus cosine inverse of 1 over 2 plus 360 degrees times n, where n belongs to z.
This angle is famous, it is 60 degrees.
Yes, so x becomes 60 degrees plus 360 degrees times n, and I have defined n right
No,
there.
plus minus, you forgot to put
Oh,
plus
yeah,
minus.
I wrote it.
Just clean it would be a mess. Yes, so we got the answers. Yeah, this is a level 3 question in math 4, but this is not actually a level 3. This is why I switched the book, you know. So, yeah. Thank you. Yeah, thank you very much. So, yes, it was very good. Thank you. So, you see that this is not that hard. Might be now you make my channel famous. This was my dream yesterday. Now it comes true. You know. Okay, so yeah, we can end the meeting here. You can have a rest, and then you can join to the other group for the first few minutes, and then you can have questions, and you can then leave actually. So thank you very much. So we end the meeting now.